Okay, cool beans. So just a quick video on how to find the equations of symmetry of a hyperbola, or the axes of symmetry. Okay, great. So what we're interested in first is finding our equations of, the equations of our asymptotes. Okay, so we can read these straight off our equation that we get given. So over here, that gives me my y asymptote equation, the equation of my y asymptote, which is y is equal to 5. I don't have to change the sign, I don't have to do anything. Alright, my equation of my x asymptote is x is equal to, you see this guy over here, that number 4, so it's a positive 4, so we change it to a negative 4, because we don't want whatever's underneath here cannot equal 0. So we've got x plus 4, so it can't equal 0, so we've got x cannot equal minus 4. So therefore that's the equation of our asymptote. Okay, cool. So once we've got that, so those are our asymptotes. Alright, so now we can look at sketching our graph. So your y and x axes, obviously. Boom, boom. Okay, label your axes. And before you start drawing a hyperbola, always draw your asymptotes first. Okay, so we have x is equal to minus 4, somewhere over here. Label that, x is equal to minus 4, and we have x is equal to 5. Y is equal to 5. That there. Okay, so we have y is equal to 5. Alright, so our graph's going to look something like that. I'll do another video showing exactly how hyperbolas work, but for now this is just our how to find the equation of the asymptotes. Okay, cool. So what we're interested in, the equations of our axes of symmetry. Okay, so this is what we're interested in over here. We have two lines of symmetry running through this graph. One of them is there and one of them is there. Okay. What we can see is that this graph here, so we have y is equal to mx plus c, but it has a negative gradient. Alright, this one over here, our top graph, y is equal to mx plus c, but it has a positive gradient. Alright, cool. This point over here, where these two lines intersect, that is minus 4 and 5. We just get that from our equations of our asymptotes. There and there. Okay, so that's our point of intersection. Alright, cool. So, normally we'd have to find our gradient. We'd have to find our m value. But with these axes of symmetry, conveniently for us, they're at a 45-degree angle. Both of them. Our angle of inclination is at 45. Okay, and the practical upshot of which is that our gradient, therefore, is equal to 1, and our other gradient is equal to negative 1. Because whenever you have an angle of inclination of 45 or depression of 45, our gradient is equal to 1. So what we know now is that our equations of the symmetry is minus x plus c, or y is equal to x plus c. Okay, sweet. So now we've got our gradient, right? Now we just have to find our c value, and we do this by subbing in a point. And the only point that we have that goes through this graph is a point of intersection of our asymptote lines. So we have the point minus 4 and 5. So that's our x value and that's our y value, and we're just going to sub them in. So we have y is 5 is equal to minus x is minus 4, we get plus c, and we have to do these for both of our equations. So we've got this one is equal to 5 minus 4 plus c. Okay, so we get 5 is equal to positive 4 plus c, so this one then gives me 5 minus 4 is equal to c, so finally my c value is equal to 1. Alright, so we just do the same procedure with this one. We get 5 is equal to negative 4 plus c. We get then 5 plus 4 is equal to c, so our c value is equal to 9. Alright, cool. So once we've done that, we just sub our c values our respective C values into their respective equations. Alright, sweeto. So we get y is equal to minus x plus 1 for that one equation, or we get y is equal to x plus 9. Okay, sweet. So those are our equations of the axes of symmetry. Okay, so just to recap real quick, is that when we're trying to find our equations of axes of symmetry, we're going to use these two equations. Obviously the one with the negative is for our decreasing line, and this is the increasing line. Okay, so we sub in the points of our intersection, sub our point of intersection, okay, which is from, we read this off from our graph, which tells us our asymptotes. It's a point of intersection of my two asymptotes. So it would be our minus P and Q. So we sub that in to find our C values. Okay, so that's just our summary of how to do it. So there we go. That's all it is. Yeah, as I said, I'll do a function video of all the functions in a later stage, but yeah, that's just how to find the equations of our axis of symmetry.